Welcome back. In this video, we'll be looking at section 1.2.2. We'll be talking about homogeneous system and subspaces. Our goal is to show that the solution set of any homogeneous linear system is a subspace. Now, to get there, we'll define a few things. So first, definition 1.2.2. I'm going to take A to be an m by n matrix and want you to think of this as the coefficient matrix of your linear system. We'll call the null space of A, null of A, the solution set of the homogeneous system with coefficient A. If you recall from linear algebra 1, we've learned that a homogeneous linear system corresponds to the matrix equation AX usually equals B, but since I've added homogeneous here, the constants are 0, so A is the coefficient. X is the vector of variables, and O0, those are the constants. We will use it in vector form because that's going to be useful in this class. So I'm going to write it this way. Whether you think of it as a matrix or a vector, you have a column matrix or a column vector for X and for 0. All right, so this is equivalent to the homogeneous linear system. So when I talk about the null space, when I talk about the solution, that's going to be the set of all vectors X in Rn so that Ax equals 0. All right, so I'm going to consider the matrix 1, 3, 1, 2, 7, 1, and I want to find the null space of it. That means I want to find a solution set of the homogeneous system, which has this coefficient matrix. All right, so homogeneous means the constants are 0, which means you can forget and not include them, but let me include them since it's our first example. So I want to solve this system. I'm going to reduce the matrix. I'm going to take row 2 minus 2 row 1 into row 2. I'm going to get 1, 3, 1, 0. I'm going to take 0, 1. 1 minus 2 is minus 1, 0. And then I need one more step. I'm going to do row 1 minus 3, row 2 into row 1. And that's going to give me 1. 3 minus 2 is 3 minus 3 is 0. 1 plus 3 is 4. 0, 1 minus 1, 0, 0. All right, so here's our reduced matrix. We have one free variable, Z, let's call it. So this one is free. I'm going to use S. And so I'm going to get, let's call them X, Y, and Z for my vector X. Here, X is going to be minus 4S. Y is going to be plus S, and Z will be plus S as well. So this is the set of minus 4, 1, 1 times S. Let me put the S in front. For S and R. All right, so that's the solution set, and so that's the null space. Null of A equals S times minus 4, 1, 1 for S in R. All right, in the note, we linked this null space back to every vector that gives you 0 when you multiply it by A. And so let's just check. I'm going to take X to be, this is part B. For X in null of A, let me take this X. I want to check that A times X is 0. So A was 1, 3, 1, 2, 7, 1. I want to multiply it by minus 4, 1, 1. I'm going to get minus 4 plus 3 plus 1, and then minus 8 plus 7 plus 1. I do get 0, 0. Notice that they're not the same size because A is not a square matrix, but it doesn't matter. If I multiply A by X, I get the 0 vector. All right, so in the next video, we'll state the theorem that tells us that all of these linear associations set to the homogeneous linear system, so all of these null spaces are subspaces, and then we'll prove that.